Cool. All right. Well, I think we should get started here. Got plenty of stuff to cover. Thank you guys for being here. I'm excited that so many people are interested in this. I feel like I don't know. It's encouraging, and I feel a little unstoppable, right? If we have like so many people kind of participating and helping with the research, then I feel like we're going to be able to figure a lot out together. So I'm excited for that. I am going to be using this Google Doc kind of in lieu of a slide deck. So this is where I'll be sharing my findings and also kind of taking notes on questions that you guys have. And I did make this document public. I dropped it in the chat earlier, but I'll drop it again just in case. So you should be able to view that, and you can have it open on the side if you want, peruse it. And I'm hoping it'll make it easier, so you guys don't have to copy down as many notes or links or whatever. Some other expectations. NLP, machine learning, this stuff is challenging, so I just want to encourage us to be gracious with each other. This is more of like an environment of like exploration and research, so we're not experts, which means I think we're going to make some mistakes. We're going to get some stuff wrong. So let's try to be gracious with each other for that. And also, I think it's okay not to know stuff. It's tough when we're in a group and we feel like oh, I'm probably supposed to know what that means, but I feel like I don't. There's little things like that I don't know all the time, and I think we have to just kind of own that and get each other's help. So I think it's already clear, but yeah, Nick and I aren't experts in BigBird yet. So the tone hopefully is that we're kind of exploring this together, not me just kind of sitting here like teaching you guys what BigBird is. But I will start by sharing kind of what I currently know, what I've learned the past week. This time around, I've had like a few weeks to get ready for this, so I've probably got a little more to share than I typically will. But and then I'm curious to see like how the discussion goes. This is the first time we've tried this. If we don't get around to a question that you've got, then we'll make sure that there's a spot in the forum to keep the discussion going on this topic. So I think that'll be a good place to kind of follow up on any questions you guys have or things you want to discuss that we don't get to in the meeting here. And yeah, so the goals for this project for me, my personal goals for researching BigBird. I want to understand the most interesting insights about how BigBird works, the architecture, what they did. I'd like to create a tutorial for it. And yeah, we kind of learned from when Nick and I studied Albert, like every BERT variant ends up having a lot of detail around it. And there's so many BERT variants, I don't think we can afford to go like too deep into the details on any particular variant. So there's kind of a balance there of like, want to explore it thoroughly, but don't want to go too far. And I think something that I guess that's great about this discussion group is I can get your guys' feedback on what you're interested in. So if enough people are interested in some aspect of the model, then we can make sure to cover that. All right. Yep. And then I want to play with it. In addition to actually just understanding the algorithm, like to work with code, see what it's like to actually work with these models. So plan to experiment with it, figure out, is it easy to work with? Is it a pain? Does it produce great results? Does it suck? And then I want to come out of that with some working example code that I can share. All right. So I've been trying to figure out the best way to handle the discussion side of this. And here's what I've come up with to try this first go around. We'll see how it goes. If you look in the chat window for this meeting, there's this fun little icon, and they've got some cool features in Google Meet. One of them is this Q&A feature that lets you basically type in a question that you want to ask, and it preserves kind of the order of the questions and in the order they were asked, and lets us like hide ones that have been addressed, things like that. So while I'm kind of sharing about what we've learned, if you feel like you've got a question that you want to discuss during the discussion part, then you can type it in there, and we'll address it then. And then for more immediate stuff, like if you catch me making a mistake, or you feel like there's an easy clarification I could make, use the chat window. You can ask each other for help, and Nick's going to monitor that for me. And if there's something that seems worth interrupting me for, then Nick, you're free to do that. And then there is that raise hand feature, and I'm thinking to use that for responding to questions that Nick and I have for you guys. So if we're curious about, like, if we open something up to the group, like, you know, does anyone have experience with this or have any insight on this? Then you can use the raise hand to be called on, basically. Yeah. And yeah, this point probably goes back up higher with up here with the Q&A feature, but I think we'll try to, Nick and I will try to assess the questions based on, you know, how in line they are with our goals and how relevant they are to everyone in the group. So we'll try to give more time and priority to questions that feel like they're, you know, more in line with that stuff. So that'll be another thing to work out, I think. All right. So let me start with what I know so far. And I think first to put BigBird in perspective, we can talk about the why it exists, I guess. So yeah, what the issues are with the original BERT that BigBird's trying to address. And it's all about handling these longer sequences of text, right? So BERT has this maximum sequence length limitation. It's limited to an input sequence of 512 tokens. And in one of our notebooks, we took an example piece of text, tokenized it, dumped it out. Let me zoom out on this just a little bit so it fits there. Yeah. There we go. Yeah, so that's what 512 tokens looks like. It's a hefty paragraph. This is a Wikipedia comment, so it's more conversational. So the sentences are a little shorter, but yeah, that's 512 tokens. So not short by any means, but definitely not enough to, you know, fit a whole like document in there. So BigBird tries to address that. And why was BERT limited to 512? I think there's two reasons for that, depending on kind of whether you're going to redo the pre-training for BERT or not. So the first one, if you're not redoing the pre-training, is that there's only 512 of these special positional encoding vectors in BERT. And I'll talk about that more in a second. And then the other is that it's kind of a performance problem. So the amount of memory that BERT uses and its speed, which impacts training time, are quadratic, meaning, you know, squared with the length of the sequence. So it gets really unwieldy really fast. So those positional encoding vectors, cover those in the ebook. Basically, this is how BERT has any kind of a notion of the order of the words in your text. So even though we kind of illustrate BERT, we illustrate the input as, you know, we put the words in order. Really, they go in parallel, and there's nothing explicit about the order of the words in the sequence other than these special PE vectors. So they get added. There's a PE vector, a different one for each position, each of the 512 possible input positions. They get added to the word embeddings before going to the first layer of BERT. Yeah, and they're only added into the first layer, not between the other ones. So yeah, and those are learned during BERT's pre-training. And they chose to learn 512 of them. So it's not a hard limit in the sense that, like, if you wanted to, you could go and redo the pre-training for BERT and learn 1024. But there's this second problem of the quadratic runtime and memory use. On BigBird, kind of jumping ahead a little bit, I was curious, like, all right, so if BigBird addresses this sequence length problem, then what does it do about these positional encoding vectors? Does it take a totally different approach, or does it just have more of them? And it looks like, basically, I started playing with the BigBird and with transformers, and in their model, there's this parameter max position embeddings equals 4096. So I suspect what that means is that they still use these PE vectors, and they Google learned or did the pre-training of BigBird with 4096 PE vectors. So there's still kind of that like hard limit that is set by the pre-training. Yeah, so that's 8 times longer than BERT. So 8 of those paragraphs that we were looking at earlier. All right, maybe the bigger issue, the more interesting one that BigBird is really about is the problem of quadratic runtime and memory use. So Google's got the authors made a nice slide deck for BigBird. It's like at least 60 slides. Yeah, here it is. So I've taken some of the illustrations out of that, and there's links in this document to that slide deck. And I thought they did a great job of illustrating the problem of the quadratic problem. So it has to do with self-attention, the whole self-attention mechanism. If you've got this example sentence, the firm for which Jacob worked sent him to New York, then you're going to compute attention scores between each word in the sequence and every other word. And then it's also like bidirectional. The score, when the attends to firm, that score is different than when firm attends to the. So it is a full matrix of attention scores that you're computing. Right, yeah, so those two are not the same. And then just kind of visually, you can see if you add another word to the sequence, then the number of attention scores is growing exponentially as you add more words. So that's the problem. And BigBird addresses it using something called sparse attention. And their goal is to make this linear instead of quadratic, meaning that every time you add another token, the number of attention scores that are computed is increased by a fixed amount. So, for example, if each word attends to 10 other words, then if you add another word, then that increases the number of attention scores by 10. Yeah, and so it means that sparse means that not every word can attend to all the others. So then the big question is, which words do you attend to? If you're not going to attend to every word, then you've got to have some kind of strategy for choosing which ones to actually look at. Yeah, and I suppose I don't entirely know all the justification for the strategies they used, but for this meeting, I can tell you what they are, my understanding of them so far. So they use a combination of 3 strategies here. The first one is that each word in the sequence attends to its neighbors, the words immediately to the left and the right, as well as itself. So they illustrate that here by coloring those squares in as blue. So we can see like the word the is attending to itself, and then the is attending to firm, and firm is attending to, let's see, firm is attending to the, right? The is attending to firm, and firm is attending to the, yeah. So that fills in kind of the diagonal there. And then they also just add in some random attention. And then I don't know the number of, I'm curious to know like how many tokens do they attend to? How many random ones? Is that something fixed or, but kind of in their illustration, it's showing that each word, in addition to attending to its neighbors, it's attending to one or two other randomly selected words. All right, which, it's funny, I thought I had some more like illustrations on that, but that's okay. All right, and then the third strategy is this notion of global tokens. So they found that just doing this wasn't enough, that there's still a need for the words to look at somehow like the entire context of the text, but without specifically attending to every word in the sequence. So they add these additional tokens that they call global attention tokens, GATs. And in this illustration, they're showing two of them. I don't know how many they actually add, but it increases the size of this matrix. So columns 1 and 2 and rows 1 and 2 are these new tokens that are added on, and the global tokens attend to every word in the sequence and themselves. And every word in the sequence also attends to the global tokens. So there is still, for every word, it still has some access to some global information about the document. Oh, here we go. These are the notes I was looking for earlier. Yeah. So I think it's got to be, in order for it to be linear, I think it's got to be this kind of like fixed quantity of tokens that each one attends to. And you know, if it were, I imagine this illustration is not the correct numbers because it's probably just for illustrative purposes, but going by it, each token is basically only allowed to attend to either 6 or 7 other tokens. It gets to attend to 2 global ones. It gets to attend to its 2 neighbors left and right plus itself, so that's 3, and then 1 or 2 random ones. And so I think what that means is that if you were to, you know, the bigger this matrix gets, the longer your sequence is, the more sparse this would look. These orange squares would, you know, start to spread out more, and you'd see a lot more white. So, yeah, so I'm kind of curious how that works. It seems like things would get worse as the sequence gets longer if you're really only, you know, if you're limiting, BigBird limits itself to only attending to 5 other words or something like that randomly, then you'd think it'd keep getting worse. So something to look into. And then I had a question, does each token only get to attend to a specific set number of other tokens no matter how long the input sequence is? Yeah. So I'm curious if my understanding there is correct, or if there's a little more to it that helps it address the longer sequences better. All right, let's see how I did on time. 7:22, yeah, not too bad. Cool. Yeah, so I'll continue to look into the architecture, and then I've been playing with BigBird using the transformers library. Right now I'm applying it to the 20 news groups data set, which is kind of this terrible data set of like forum posts that are not really that well labeled, and it's sort of a tricky task. But what's good about it is that I've found from experimenting with it that a lot of the newsgroup postings are longer than 512 tokens. And it seems to be the case that the longer the input sequences that you're able to accept, the better BERT does on the benchmark. So it's one where document length does actually seem to matter, whereas in other data sets we've played with, it's like you can just truncate and there's almost no loss in accuracy because there's just not that much critical information in the conclusion of the document or whatever. And yeah, so what I've got so far, just from initial playing around with it, it was pretty easy to get going. Like Transformers does have a BigBird class, and Google did release their pre-trained models. So it's kind of just some quick substitutions to get going with it. However, with a single V100 with 16 gigabytes of RAM, I was able to truncate to 768 tokens and use a batch size of 4. And that used something like 11 or 12 gigabytes of the available 16. So I can go a little higher than this, maybe increase the batch size to 6 or the max length maybe to 1,000. But pretty soon, it looks like we'll need multiple GPUs in order to actually like really apply BigBird fully, to significantly longer documents. Yep, I'll keep reading the paper. All right. So I did want to ask if anyone had experience applying multiple GPUs with the Hugging Face Transformers library, because that'll be kind of a next step for me. I've used Amazon EC2 before for renting GPU instances, so I might start there again. Sure would be cool if like Colab had an option for letting me connect to more than one GPU, but as far as I understand, that's not really a thing. So kind of have to change the whole environment, connect to a EC2 instance, set it up. It'll be harder, but should be kind of fun too, I guess. Cool. So questions, I think, yeah? Pulling up the Q&A section here. So John, you were asking, has anybody heard of customizing position embeddings, those PE vectors, to encode things like non-linear sequences of tokens? How do you have a non-linear sequence?
So in our field with scientific text mining, things like chemical formulas, where the order of the elements are irrelevant to the actual meaning of the token, so the subtokens that BERT breaks it up into, those position embeddings are not very relevant to the model learning anything. And so we're very interested in, can you kind of sandwich them down into just a single position embedding so that you can actually learn what those individual tokens learn, that they can be interchanged? Because I think BERT gets a little bit confused by that when they appear in different orders, but they mean the same thing.
Interesting. Okay. Can you like, it's like, can you simplify the number of PE vectors, or maybe it's like, it sounds kind of like you'd want to assign the same PE vector to...
Yeah, we thought about doing the same one.
Yeah.
And then also, if you have co-reference in other parts of the text, I thought that you may be able to leverage that somehow in interesting ways. I don't know if it would lead to any interesting behavior. That's kind of, I was wondering if anybody had heard anyone experimenting with that.
Let's see. Sorry, could you repeat that? I kind of missed the beginning.
Yeah, so if you have co-references in a piece of text, that may be different tokens or something like that, and you want to more instead of understanding the whole text, you want to build a better representation for that specific one, given that context. Whether that would lead to any interesting behavior if you kind of mess with the position embeddings. So if you have named entities in the text, for example, putting those all closer together artificially in the beginning or something in order to just get because if they're far away from each other, like one's at the beginning of the paragraph and one's at the end, they're not going to tend to each other very strongly most of the time. And so they're not going to bias each other as much.
I see. Yeah. So they're co-references, meaning that they're different names, basically different names for the same entity. If that's the example.
Yeah.
Yeah. Yeah. You're trying to get BERT to understand that they are the same.
Yeah, just leveraging structure that you already know about in your documents rather than just treating it as a totally black just list of tokens.
Cool. Okay. Yeah. Does anyone on the call have some experience with that, or any perspectives for us? Let's see. Being new to this, I see on my screen I see like 8 people's possible webcam feeds, which means I wouldn't see if any of the other people were raising their hand. So Kate or Nick, can you guys see if
we don't have any hands up yet. I'm keeping an eye on that.
All right, cool. Okay.
Yeah, I would wonder, taking a stab at it, is because co-reference resolution is sort of one of the problems that BERT kind of seeks to tackle, or like transformers seek to tackle. I wonder if you look at kind of like BERTology, if you look at how the weights are kind of attending to one another, if you have a nice like BERT visualization, I think it does a pretty good job of like basically untangling these co-references. I don't know at what kind of length dependency that falls off. But are you suggesting like during pre-training, you either add some kind of label or you like artificially somehow try and teach it with the pre-training data?
Yeah, so for example, chemical formulas and the names of those compounds are mapped together very strongly. So FeO2 and iron oxide, and you know that those are going to be a co-reference in your text even before doing any pre-training with BERT.
Yeah.
And so if you want to learn a better representation for FeO2 and iron oxide, making those somehow basically just, what we've been doing is just removing the word iron oxide and replacing it with chemical formula so that you're mapping them onto the same concept. But then, if you then have iron oxide and iron sulfide, there may be similarities there that you're losing because you've mapped it onto a single token. So we're just trying to play around with ways of leveraging structure that already exists in documents. Other things might be like names of places and abbreviations for those things, acronyms, that kind of stuff. Right now, you're kind of forcing BERT to learn it from scratch when you sort of already know what those things are. So I was thinking maybe somebody had already tried this somewhere and then would be able to leverage and give us some like feedback.
Very anecdotally, I've tried a bit of this and have done this in a few solutions where, for example, some kind of business intelligence platform, you substitute all of the company name and all of the company name aliases. You just substitute for a single token that says company name throughout. And anecdotally, I saw some pretty good improvements with this where it didn't have to try and figure out that these are the same thing. You basically just do pre-processing of the text and teach it that this substitution means we're dealing with entity one. I wonder, I mean, I don't know how much that applies to something like your domain.
Yeah, we do that with numbers very frequently. And then units and of properties and stuff like that.
Mm-hmm.
Yeah, it works really well when you do that, because then it can just sort of just see a thing that looks like like a number, and it knows things that are next to numbers tend to be units or stuff like that. So.
Yeah.
Okay, thanks.
Yeah, so I wanted to make sure I understood the flip side to making those substitutions is that you've now simplified the vocabulary a bit, and there's things that BERT can learn about the meaning of words, based on their use in the text. So if there's I think you were saying there's similarity between iron oxide and was it like iron sulfide or something like that?
Yeah, that's just a random example.
Yeah. So if you substitute iron oxide with the chemical formula for it, then BERT isn't getting to learn about the meaning of the word iron, I guess, right?
Yeah.
Okay.
And then there are also other sub not just when you have iron sulfide, but you might write the word hematite, which is another kind of word that means a chemical formula. But heme also is a Latin abbreviation or a Latin prefix from iron containing. So, and then tite, ite things are minerals typically. So there's just a lot of vocabulary used to describe chemical compounds that we simultaneously want good representation within the text, but we still want to leave them in a way that allows so within a piece of text we want this instance of this compound has these properties, because the way that you make your samples or something like that affects their properties a lot. But there's also this concept of more general what it is. But when you discuss something like Apple or Steve Jobs in a piece of text, that usually doesn't have as much, it's just a single person or a single entity, and the representation you want for them is not changing much in the piece of text. You might color it a bit with what they're doing in the text, but everything about them and kind of the classification you would give to them doesn't change as much. So that's what we've noticed, is that it doesn't do as well for this representation task as something like WordDevec does, because WordDevec is a very global representation of that token. Not to mention it runs exponentially faster, but yeah. But we do want contextual information in it. So if there's some medium between something what a WordDevec would do and then what BERT will do, that's something we're interested in.
Cool.
Yeah, it's interesting. I haven't run across any research addressing that specifically, but it's a very interesting problem to try and both pull out the subword information while preserving kind of the whole entity kind of thing. Yeah, I can only think of really hacky solutions where you take the original and then add entity 5, and you squish them next to each other, so it tries to learn that. Yeah, I'd be curious if there's a more kind of finesse approach.
We started playing with emojis, as using them as because also the SEP tokens tend to transfer some of the meaning across sentences and stuff, and so you can artificially add some weird, not necessarily SEP tokens, but you can add kind of tokens that you wanna, if you put a hugging face emoji in front of both references, that's sort of linking them together. Things like that, your solution. But we don't have any good quantitative results yet. We're still building out our infrastructure for doing training in parallel of multiple models where we try different things out. Right now it's very manual.
I think, if I could talk, for what you're discussing, with at least for biomedical entities, if you wanted to do something where you pre-trained like synonyms of like the same entities, so that in this like BERT space, they would be closer to each other, right? Like you learn. I put 2 papers in the chat. One that does that, like from last year's. I'm not sure what conference that was, and then that could be useful if it's very, like as a pre-processing method, I guess, if you want, if you know what your vocabulary will look like in some sense, for biomarkers, I guess. And then the other thing is, there is this matching the blanks paper that Google put out like 2 years ago, where they introduce, it's more for like learning relationships between entities in your documents, but they use these like entity markers that they put around the entities in their text. I don't know if it does exactly solve what you're trying to do, but in some sense, because for them it's like, it's not so much synonyms of the same sort of biomedical entity, but maybe it could be used like towards that end.
Oh, that looks really good. I'll have to read those. Thanks.
Okay.
Cool. Thanks, guys. Let's see. Bartaz, you're asking about where the recording will be. Yeah, something I've got to figure out. I have to decide what to do with this content in the webinar and stuff. I think for this first one, I am going to put it up on YouTube, so should be able to access it there. I can add it to the BERT collection as well, so for sure, yeah, you should have access to it. Let's see, Diogo. Chris, have you tried to use BERT or any transformer architecture in non-NLP problems that have sequences in their heart OFC? I've seen some people talking about applying transformers in supply chain problems, for example. Right. Yeah, so I haven't done that, but I do know that in BigBird they applied BERT to some genomic data. I haven't read that section yet, but I'm pretty curious about that. So that seems maybe in line with what you're talking about.
Yeah, you might want to try out. I found this sort of Google created a benchmark for longer sequence using like either attention mechanisms or one of these kind of sparse attention mechanisms like BigBird and WinFormer and Reformer. But this long-range arena, instead of just being long text documents, there's a set of other tasks, and one is, I think 1 or 2 are genomic. One is like a kind of weird order of operations where it requires the transformer to basically like resolve sort of relative subclauses within larger clauses and obey like order of operations. And one is like a sort of weird pathing problem. So I think there is like a lot of very like wide range applications in there. If you look at the paper, there's like a description of each task and why they included it and why they think it's sort of helpful. But if your problem is long range dependency generally, independent of whether it's text or independent of the mode of the data, there might be some insights there for you to look at. Oh, and they also benchmark BigBird against the other kind of sparse transformers, so you have some indication of how well it performs versus the other kind of variations that are trying to make transformer architecture sub-quadratic. But it's quite nice because all of these papers like have their own benchmark, so it's kind of like a glue for long-range architectures.
Thanks, guys. Sorry for my bad English firstly.
Not a problem.
But that's the point. I don't talk English in my daily basis, but I can try to talk a little bit. The point I'm talking about is that we can approach any problem with transformers that has a sequence, like time series. So when I said supply chain is one kind of a problem that firstly we think about graphs, maybe nodes and the connections and what's the best path, or the shortest path. And transformers, because of the attention mechanism, it can tell us that sequence. I want to go from place A to B to D to F. What's the next place that I have to go for my? So it can many times tell us the best approach to, or the best route. Okay, now I will stop talking a little bit.
How
I'll go, yeah.
how does it do
I'm
that?
not aware of any of these benchmarks being on, like pathing in graph networks or something like that, which it sounds like you're interested in. I'm not aware, but I'm sure it's, maybe in long range arena. I don't quite remember all of the benchmark tasks, or maybe elsewhere there is this kind of research to say, this applied to long range graph networks. I'm not quite sure.
Yeah, Nick, there's a couple columns in their table that say path. They've got list ops, text retrieval, image path, path X.
The path X is, I don't quite understand it, but it's sort of like a...
They'll fail it, so...
It's like a looping, basically series of dashes through a two-dimensional maze, and you have to understand if the head and end of the maze are connected by these dashes, or if the dashes do not connect these two nodes.
Wow.
It's hard to understand right off the bat whether that's equivalent to your problem, Diogo, but it might be worth looking at.
Sure, no, I don't have any problem, but I just want to point that there is other problems that can be solved with transformers, and any problem that is a sequence on it, we can try maybe a transformer and get good results. So it was just a point, no problems to be brainstormed. Okay.
So that would be like a sequence to sequence problem. Is that right? You give it.
Yeah.
Man.
Yes.
You give it the graph as a sequence of nodes, and then have it output a sequence that's the path to take?
Sure. Yeah, you can maybe mask the start of a sequence and ask for your model to respond. What's the next warehouse in a supply chain problem, for example?
Okay.
I've seen work done with like transformers that operate on graphs. That's starting to make the entire field a little bit too.
Sure.
I can send you some papers, Diego, if you're interested.
Yeah, that's really interesting. How do you feed a graph into BERT? Given that a graph is like a structure with all these connections, and BERT just takes in sequences.
So it's not necessarily feeding it into BERT, but you basically, I mean, you can do a few ways is randomly walk it into sequences. You can apply attention at the node level. So it basically attends to the everything connected to it. Because if you just get rid of the position encodings, then all of those nodes existing in that, or tokens existing in that document are all connected together. And so people have been using these attention mechanisms in the transformer particularly to try to get node and graph level features out of these data structures.
Interesting.
I think we need to give it some sense of position to it, right? To this graph.
Yeah, so usually you start centrally and then you work your way outwards to build the representation for a single node.
Sure. Yeah, no, just talking because randomly we can't put it in order. Give it.
Yeah, I haven't worked with those methods myself much, but I've seen them used, so maybe I can send you those papers and background they come from, and you can take a look too.
Cool. Yeah, I wasn't familiar with that, so thank you. Let me switch back to the questions here, see if there's some more we should try to tackle. How are we doing on time? Should be paying closer attention to that, probably. Right. Yeah, so John, you also asked about whether BigBird has been benchmarked against simpler solutions like breaking the text into parts and then recombining them in some way. Yeah, I think that's a good question. That's probably something we can. I wouldn't be surprised if that's covered in the paper. And then if not, we can try that ourselves, I think. Yeah. So BigBird versus, I'm gonna call it like chunking. Cool. Yeah, so someone asked in the chat whether Transformers supports detecting multiple GPUs and distributing the load. So I would love to know if anyone has used multiple GPU systems.
In discussion.
Sorry.
I already answered it.
Oh, okay. Nice. I have to bounce back and forth here between the Q&A and the chat. Let's see what I think of that. So Diego, what's the answer?
I said that transformers use the trainer approach from PyTorch Lightning, and there they can set the number of GPUs, etc.
Okay.
There was even some discussions with William and the people from Hugging Face because of it. And Abhishek Thakur made some jokes with the first API and faster API, etc. And William didn't like it when they borrowed the approach. He said, William Falcon, he said that it's not good for the community. But okay, it's good.
He borrowed the trainer approach from PyTorch Lightning. Okay. So that's sort of a paradigm for defining a multi-GPU task.
William said that the code was even just a copy paste in phase library.
Cool. Okay. Well, I suspect that next week I'm going to have some stuff to share on that topic because I think I've got to switch to a multi-GPU setup here.
Are you going to use AWS or Lambda?
I haven't used Lambda for, I mean, I haven't used it period, but I definitely haven't used it for this kind of stuff. So Lambda's cheap, right? It lets you.
Yeah, it's a lot cheaper than typical options.
Interesting. Can you run? I guess I was going to ask if you can run Python code on it. That sounds.
Yeah, it's all pre-set up to run. You can even get it with like transformers built into it.
Interesting. Okay. Thank you.
You can add the libraries, but I don't think you can use the GPU in Lambda service.
No. I'm not talking about AWS Lambda. I'm talking about Lambda Labs, the GPU servers.
Okay, sorry. Yes.
Gotcha. I had the same misunderstanding.
Yeah. Yeah, so they did a benchmark where using similar levels of GPUs would be like, I think half the price on Lambda Cloud. And so you can just basically provision a 4 to 8 GPU server. So if you're in that medium stage, it's a pretty good option.
Got it. Okay. Right.
Yeah.
It would be cool if Amazon Lambda supported it, because that's like really cheap.
Yeah. $1 for response.
Yeah. Yeah. So I guess, John, my first thought there is like, I've already used EC2. I kind of, I know how to set up an instance there. Like, how hard is it going to be? How long is it going to take me to like get set up, on Lambda Labs? Which I'm sure
it was super fast.
Yeah.
I found it really intuitive. If you already understand sort of when you set up an EC2, you get a key, and then you log into that. So you set some environment variables. It's very similar.
Okay. Cool. Yeah, I'll have to take a look at their pricing, I think, then, and see. All right, let's see. Probably we got a few minutes left. I'm just going to skim the questions here to see.
Yeah, Michael F. asked, is there a code for how to use BigBird? Yeah, they added it to Hugging Face like in the last week or two. So you can, I haven't looked at it yet, but it sounds like they have example code running, and it's sort of one of the, not just community models, but one of like the supported models that they've built out classes for.
That was in the last week or two?
I saw release notes. I thought it was earlier, but then I saw release notes, and they released this like BigBird blog post.
Right.
Last week, essentially. So
that's funny. Yeah. We're a little close to the edge here. Yeah. It's nice when things are established and the kinks have been worked out. So I guess it's great that it's there. Good timing that, I'm glad we didn't start this 2 weeks ago. Yeah, transformers for stock market predictions, ordinal or interval scaled categories. Yeah, I think handling categorical information or ordinal stuff. That's, yeah, I'm pretty interested in that as well. I think that's a topic we'll probably get to eventually here. Synonyms extraction, concept generation. Okay, so I think since nothing else is like too specific to BigBird, let's just kind of go down the list. BERT for synonym extraction. What is synonym extraction? Is that the same as co-reference resolution, where you're trying to identify like these two things really mean the same thing?
Can I answer your question?
Yeah.
Okay, hello, this is Rawan from Saudi Arabia.
Hey.
This NLP researcher, and I was interested in your series. Thank you very much.
Yeah,
this was very useful, and I really like it. So, synonyms extraction, I mean, when there are two words that have similar meaning, I've tried to do that using Elmo, word-to-vec, something called dict-to-vec, and the best results were obtained by using continuous type of words with the cosine similarity. I did some filters like lemmatization, collocations, and POS, and I obtained good results. However, I was thinking of using BERT for this task, and it was based on the word level, not the sentence level. When I was trying to use BERT, I need to, feed the model with some sentences, not words. While in my task, I'm trying to find the word. So that was the problem. So I was thinking if you have an answer for this. Thank you.
So it sounds like, right, yeah, it's like a big difference between BERT and Word2Vec is that Word2Vec learns these global embeddings from a big repository of text, and then BERT generates embeddings from text that you feed it, and so the embeddings are contextualized. So they do almost kind of have different, pretty different uses, it seems like. So, and it sounded like what you were asking specifically is that maybe your problem statement is better suited to Word2Vec, and that you kind of just want like a single representation for each word. Maybe my question is like, are you trying to find synonyms in a vocabulary, or identify synonyms in an arbitrary, new piece of text?
Like the vocabulary, Grammarly? Do you know Grammarly? For sure. So sometimes it's just for you a visual word for this context, and I think it's for the same reason. Actually, it was for a game. I was working on a game, and I want to generate the game content using automatic methods. So I put a word for them, and I want them to choose 3 synonyms for this word among 6 words. And it was a very successful game. They asked me to put new content, and I was thinking, can we do that using the NLP technology? So I started with the Word2Vec. Then I was thinking of BERT. It's just a question. I already finished my master thesis, and I forgot I got my master. I want to practice it. And this is, in simple words, just how to work like a dictionary. If you want a better word, another sentence, like if you search in Google for a sentence.
Right.
I've seen people do this before. So one way you can do it is take all of the contexts that occur in your corpus and just average the word embedding that BERT generates for that word in that context. The other way is you can have kind of a no-op context where you just say your word token is a word, and then you use that one. And so when you use the same rest of your sentence for everything in your dictionary, then they sort of like you just average away the context so that when you use cosine similarity of the embeddings BERT generates, it's more consistent with something like word2vec because they all have the same context. So those are the two ways I've seen it done.
This is great. Can you provide a link or something, John?
Yeah, I think I saw a Medium article.
Thank you very much, all.
So what was the if you use the same context every time? What's in that context again?
It can be anything, really. You just need it to be the same and something that's like really bland, so that it doesn't push the embedding direction very far away from just kind of like the notional of it.
Interesting. Cool. Yeah, I've wondered about that. It's always seemed like it's like even though they both deal with word embeddings, it almost feels like they're word2vec and BERT. Sorry, it seems like they're very different because of that sort of global versus contextual nature. But those are interesting.
Yeah, I don't know if you get that much better performance from it. It's just what people try to do. So for example, word2vec. The pre-trained models for word2vec may not be trained on as much text as something like BERT was. So people try to use these pre-trained models to get better word embeddings without having to train them themselves. So. Also, you can choose the context. So if you wanted to only get the meaning of a word within biomedical documents or something, where that context is important, but you still wanted a word embedding, rather than retraining your entire model for that, you just give it a bunch of biomedical documents and then average the meaning within those documents, something like that.
Yeah, again, without like the goal there is like avoiding having to completely redo the pre-training yourself. Cool. Okay. Well, I think we're 6 minutes over. It's funny. One of the things I didn't think through is like, how do we end this? How do we wrap it up? But I think I'll end it by saying thank you guys, and I think we'll do this again next week, and I will send out some kind of link, I think, to where you can look in the forum to kind of pick up the discussion. And I'll let you guys know too when the recording's available. So yeah, thank you. This was fun. We'll see you guys next week.
Thanks, good.
Yeah.